Everyone, welcome back to my channel. Today's video is extremely valuable for anyone who preparing for an RTL design interview, especially at Cadence. So these questions are highly relevant. Actually, asked in Cadence interviews and mastering them will boost your confidence and performance. So let's begin your preparation the right way. So let's start with a very common cadence question. How is a ledge input in Verilog and how do we avoid unintended latches? So what is latches? A latch is input when a combinational block doesn't assign a value on all possible paths. So for example, if you write an if without an else, the synthesis tool assumes you want to remember the previous value and then create a latch. So to avoid this, always provide default assignment at the top of the combinational block or use complete if-else and case structure. Cadence asks this check if you write clean, predictable RTO that avoid timing problems. Good latch-free coding instantly tells the interviewer you understand good design practices. Next question. Cadence love this fundamental question, that is what is the difference between always at the rate bracket asterisk and always at the rate bracket positive posage clock. So first one is purely for combinational logic and it reacts to any input change and must cover all possible input condition. And second one, that is always at the rate of posage clock, is for sequential logic. So it models flip-flop and updates value only on the clock edge. Your interviewer wants to see that you understand the hardware model, not just coding. Separating combinational sequential logic is essential for writing clear synthesizable RTL. So let's talk about metastability, a very important hardware concept, especially metastability occurs when a flip-flop captures a signal that is changing too close to the clock edge. The output can enter in unpredictable state that may take longer to stabilize. We fix this using synchronization, usually a two flip-flop synchronizer for control signals and FIFO or handshake for multi-bit signals. I've already described synchronizer and CDC issues in my previous CDC series videos. So if you want to learn more about CDC, you can check there. So coming back to this question, Cadence focus heavily on CDC concepts. So explaining metastability confidently makes a strong impression. So this question often follows metastability. Explain a two flip-flop synchronizer. So one flip-flop capture the asynchronous signal. It may go metastable. The second flip-flop samples that value on the next clock cycle. So this drastically reduces the probability that metastability propagate deeper into the design. So this is the most standard CDC solution. Interviewer Cadence expect you to explain it very clearly and understand why it works. So this question is a real world debugging question. Why do simulation and synthesis sometimes give different results? So typical reason includes missing assignments causing latch interference, wrong sensitivity list, use of delayed statements like hash pipe which synthesis ignores, right? So, unknown states dependencies in simulation using non-synthesizable constructs. So, uses this question to see whether you can think beyond simulation and handle real hardware constraints. So, showing debugging awareness gives you a strong advantage, of course. Another very important question is timing, that is setup and hold time. What causes setup and hold violation and how do you fix them at RTL level? So, setup violation, data arrives late. Fixes include adding pipelining, reducing logic on the critical path. Hold violation, data arrives too early. Fixes include adding delay or register, balancing combinational path. Even though physical design files fixes exist, Cadence expects RTL engineer to understand how their code impacts timing. Answering this clearly shows maturity in digital design. Now, next question, clock domain crossing or CDC is when signals move between different clock domains. Because clocks are unrelated, metastability and data corruption can occur. This is why we use synchronization technique such as two flip-flops in FIFO or handshake mechanism. Cadence interviewers ask this to ensure you understand real silicon issues, not just coding. CDC knowledge is mandatory for any model, SOC or IP. Next is a practical RTL coding question. Implement a three-stage FSM, ideal, read and write. When answering, don't just write code, show structure. Use separate blocks for state register and next state logic. Then give default assignment and then handle illegal states. Use readable states in coding. FSM coding quality tells the interviewer how disciplined you are as an RTL designer. A clean FSM answer really strengthens your impression. So focus on FSM related questions. Do more and more FSM coding, which boost your confidence and you are near to crack your interview. Now, a race condition happens when the order of execution affects the result, usually because of blocking assignment in sequential code or multiple drivers for one signal. Avoid them by using non-blocking assignment for sequential logic, avoiding multiple drivers, keeping logic in well-structured always block. Cadence interviewers are this to check if you understand simulation semantics and determinism in hardware. Now, a combinational loop is when combinational logic feeds back into itself with no register in between. This causes oscillation, unstable behavior, or synthesis error. Tool detects it, but clean coding prevents it. Fixing a loop usually means inserting a register or restructuring the logic. So this question checks if you understand synthesis state design technique. And that completes your Cadence RTL design interview preparation. If you master these questions, not just memorize them, but truly understand them, you will enter your interview with absolute confidence. So remember these questions are actually asked in Cadence interview. So practicing them gives you a real advantage. So thank you for watching. If you found this helpful, don't forget to like, share and subscribe. And drop a comment if you want more Cadence, RTL or verification interview videos. All the best for your interview. You can crack it. Believe in your preparation. Thank you for watching.